pollutants have been a growing issue in our environment. This has been severely affecting our country's natural resources, health, and commercial industry.
Pollution in both coastal land and wetland ecosystems, especially in industrial zones in Cavite, pose serious ecological and vigor threats due to the persistence of pollutants like heavy metals, organic solvents, and agrochemicals. The mentioned pollutants are linked to multiple serious health concerns like carcinogenesis, neurotoxicity, and ecosystem degradation. But what if we told you that mushrooms, despite being known for its wide use in cuisines, can actually be the superhero we long for? Now you may ask, how can we amplify this newly found solution? Well,
Mycelia, as described by Knott in 2024, is the underground vegetative part of mushrooms that possesses multiple advantages while thriving in harsh conditions. This part gives the mushrooms the ability to sense biological and chemical signals and respond to various inputs.
microremediation is a biotechnology that utilizes fungi to eliminate toxic contaminants and pollutants from the environment. It serves as a cost-effective and eco-friendly solution. Building upon these findings, Robo PLEURO proposes a hybrid system that combines robotic sensing with living fungal remediation.
Robo PLEURO aims to design, construct, and evaluate a robotic biohybrid system, integrating fungal mycelia with embedded biosensors for pollutant detection and remediation in industrially contaminated areas. Since this study will investigate the use of a robotic biohybrid system powered by Pleurotus ostreatus or oyster mushrooms for soil remediation using naturally excreted enzymes,
Multiple individuals, farmers, communities, organizations like DENR, industrial stakeholders, and scientific or academic institutions will be benefiting from this study.
The development of Robo PLEURO went through these steps: designing, gathering, assembly, and field testing. Now let us understand the set phases on a deeper level. We started by sketching PLEURO to plan the placement of its pH, moisture, and ultrasonic sensors, the fungal chamber, and robotic parts. The design kept the system compact while ensuring that each component worked properly in wetland terrain. In gathering materials, electronic parts like Arduino microcontroller, sensors, motors, tracks, battery, and LEDs were purchased online. The acrylic chassis came from the shop of the qualified scientists in Cavite City, while the oyster mushroom culture was sourced from Profeta's farm in Tanza, Cavite. In the assembly of Robo PLEURO, the protein bag containing the Pleurotus ostreatus or oyster mushrooms was carefully placed into the fungal chamber at the center of the chassis. This stable placement allowed the mushroom culture to serve as a biological core of the biohybrid, working alongside the sensors and microcontroller. And lastly, for field testing, PLEURO was deployed in a simulation in a polluted lot in Naiklabac, Cavite, where it successfully navigated terrain, identified acidic hotspots, and stopped for remediation. Data from the sensors confirmed the detection of pollutants and validated the robot's effectiveness.
Data revealed a 100% functionality rate on the pH, moisture, and ultrasonic sensors. It was also discovered that the transmission rate of the biohybrid was efficient and effective. Ultimately, there was a significant difference in the robot's navigation behavior between polluted and non-polluted environment. In essence, the findings of this study lead to the rejection of the null hypothesis and confirm that Robo PLEURO represents a significant step towards eco-friendly, cost-effective, and adaptive solutions for pollution management.
we recommend integrating the robot biohybrid into a third-party application which will map and monitor PLEURO's activities. The app will provide the mapping of PLEURO's area of focus, leaving pins wherever it detects acidified or polluted areas. In addition, PLEURO, specifically the fungal component, will benefit from a humidifier in the fungal chamber.